or this video would be to understand the construction and the working principle of thermocouple and thermistor. After watching this video, you should be able to differentiate between thermocouple, thermistor and RTD, and you should be able to identify a proper temperature transducer for a specific application. Let's start with the construction of thermocouple. The thermocouple is based on the principle of Seebeck effect. Thomas Seebeck discovered it in 1821. He states that when we have two different metals, here denoted by red and the blue lines, one is maintained at a hot temperature and another junction is maintained at cold temperature by keeping it into ice or water. When we connect a meter, we see a voltage or EMF generated across it. This voltage between the hot and cold junction is an EMF which increases as we increase the hot junction. That is, the voltage is a function of temperature between them. To understand thermocouple, there are three more laws of thermoelectricity: the law of homogeneous circuits, law of intermediate metals, and law of intermediate temperatures. Let's look into the law of homogeneous circuit. It states that the net thermo EMF generated is dependent on the material and the temperatures of two junctions only, not on any intermediate temperature. Let's understand this. In this picture, we are able to see two metals which are connected and forming a junction, a hot junction as well as the cold junction. But observe that here both the metals are similar or same, and hence the EMF generated across these two metals would be zero. The second law of intermediate metals is stated as if a third material is introduced at any point, it will not have any effect on the junction temperature. That means if we have these two metal wires connected with a third one shown in the green, and we still have the hot junction and the cold junction, then the voltage generated would be same EMF as that of the different metal ones. This law makes it possible to insert a new measuring device without forming a new thermocouple with the existing one. The third law is very important for calibration of thermocouple. It is the law of intermediate temperatures. Consider we have two dissimilar wires with two junctions formed J1 and J2. Here we maintain one junction at a hot temperature and another junction at a reference temperature T2. Then we get the EMF as E1. Now if we interchange, that is, if the first junction is maintained at the reference temperature and the next junction is generated as the cold junction, then we get an EMF of E2. Now we can say that E3 is an addition of EMFs of the first case as well as the second case. Let's look at the different combinations of the materials which are used for the thermocouple manufacturing. There are many combinations which can be possible, which is shown in the graphs. There are different types of thermocouples which are available: type E, type J, type K, and so on. If you observe, the type E, type J and type M have a linear variation with temperature and voltage. Type E is a chromal constant, whereas type J is a ion constant. Type K is chromal alumel, which is very frequently used in most of the applications. Now that we have understood the basic construction and the principle of working of thermocouple, plus the different materials which are used for constructing a thermocouple, let's look into a small application which would give us an idea how thermocouples are calibrated. We have a chromal aluminum thermocouple with the following table given. I would request you to pause the video and try to solve the sum on your own. I hope you have solved the sum and got a proper answer. What we have to do here is we have to find out the actual hot junction temperature. Remember, in thermocouple, we always get a difference of temperature and not an exact or absolute value of temperature as a measurement. So here we have the given data as T1, which we have to find out. T2 is the reference temperature, which is given here as 28 degrees Celsius, and T3 is the temperature which is maintained at the cold junction, that is 0 degrees Celsius. If you see, for 28 degrees Celsius, we already have the value as 112, and it is given in the problem that the reference temperature, at reference temperature, we have 26.25 millivolts. So we have the values of E1, that is at temperature T1, is 26.25, plus from the table we have taken for 28 degrees Celsius 1.12, and we have got an EMF which is generated as 27.37 millivolt. This EMF which is generated is then given to the next unit to calculate and give to the further application. Let's look at the advantages and disadvantages of the thermocouple. The first and foremost advantage is it's simple and rugged because it consists of only two wires of dissimilar metals. The high temperature operation is due to the different types which are available, and the range goes up to few thousands of temperature. Since the construction is very simple and consists of only two wires, it's low cost, and the most important application or advantage of this particular temperature transducer is the fast response. That is, once the temperature is sensed, the response to the instrumentation unit is very fast. There are, as usual, some disadvantages of thermocouple. The stability and the repeatability of thermocouple is much lesser compared to the other transducers. It has low sensitivity, means it cannot identify small changes in temperature. The next disadvantage is when we need to connect the thermocouple, that is, if the temperature measurement area is pretty far from the instrumentation unit or the unit which calculates the temperature, then the wires should be of the same type. Then, since we have long wires connecting it, we would have more interference of noise. And the last disadvantage is because of the above disadvantages, we have, compared to the RTD, a lower accuracy in the reading. With this, we finish the basic construction and applications of thermocouple. We would now look into the last type of temperature transducer which we'll be seeing in this lesson, is that a thermistor. Thermistor is basically a combination of two words, that is thermally sensitive resistor. So out of that, therm is taken and istor is taken. This is the symbol of thermistor. Basically, thermistor is a change in physical resistance when exposed to temperature. The operation being similar to an RTD, but the constructing material which is used in thermistor is usually a ceramic material, as oxides of nickel, magnesium or cobalt. So there are two types of thermistors. One is negative temperature coefficient thermistor and another is a positive temperature coefficient thermistor. These both are separated by the way they work. So the negative temperature coefficient, the resistance decreases with increase in temperature. But observe, it's not a linear change. And in case of positive temperature coefficient, for a small range it is linear, and with increase in temperature the resistance increases. The NTC, that is negative temperature coefficient, rely on the equation of RT equals to R0 into e raised to beta 1 upon T minus 1 upon T0, where RT is the resistance at a temperature T, R0 is the resistance of the material at 0 degree Kelvin, beta is a constant related to the material used, T is the temperature at which we want to measure the thermistor resistance, and T0 is the temperature or the reference temperature. Remember, the temperatures for these calculations are in Kelvin. Let's look at the advantages and disadvantages of thermistor. The advantage of thermistor transducer is its output is directly a change in resistance which can be taken as it is. We do not have to measure any other or provide any kind of compensation or reference junction as in case of thermocouple. Second advantage is it is relatively easy to measure. A simple potential divider can be used to measure the change in resistance in thermistor. The disadvantage being, in thermistor we have the self-heating problem, wherein since it's the change of resistance, it is again related to the power, and which in turn, if power increases, we get heat dissipation which is generated, and which is the self-heating power. The second disadvantage is it is more expensive than the thermocouple, since we have to use different metals or oxides. And the third disadvantage would be the slow response. That is, once you measure, the instrumentation stage will get the resistance change or the temperature change in a slower time as compared to thermocouple. So this completes the thermistor and thermocouple lesson, and which in turn completes the temperature transducer. Thank you.